Hey math kids, today we're going to talk about trig identities, and let's just start with some examples. Alright, so on page 234 in your book, there's some trig identities listed, and really it's just like a way to substitute into expressions or equations with different trig values, or trig, what am I trying to say? Trig expressions. So, okay, the first thing is we're just going to treat cosine like it's an x. So if we had 3x plus 4x, we would get 7x. So in this case, we get 7 cosine theta. Okay, not too bad. Now we have tangent alpha minus 3 tangent alpha. So this is like a 1. So it's just 1 minus 3, which is negative 2. And we have tangent alpha. Okay? Then the next section in your book shows not next section, but right below that example that I just did, we see a bunch of negative angle formulae, and we're going to have to use that on this next one. So we have sine of negative theta plus 2 sine theta. So if we look at our negative angle formulas, we see, so I'll just write the relevant one, but we have one that is sine of negative theta is equal to negative sine theta. And so if we use that, we're going to replace this with this. So we get negative sine theta plus 2 sine theta. So that's really just negative 1, positive 2. So we just end up with sine theta, or just 1 sine theta. Okay? Now we have new problem, cosine of pi halves minus theta over cosine of pi minus theta. Okay, so I'm going to write down a couple relevant formulas from that part. So we have cosine pi halves minus theta equals negative cosine theta. So this top one, we're going to replace the top with this thing. So we get negative cosine theta. Okay, and then another relevant one that we're going to do, we have cosine pi minus theta is equal to negative cosine. Oh wait, I mixed these up. Sorry. That top one is actually supposed to be sine. So this one is just sine. Sorry, when I was looking over at the thing, I messed up. Okay, so this one is true, and then we get negative cosine theta. Okay, now if we do sine over cosine, that's tangent. And then since it's negative, we're just going to put a negative out in front. Okay, now we're going to talk about the Pythagorean identity. This one showed up in math 2 as well, but I'll just show it again. So it's sine squared theta plus cosine squared theta is equal to 1. And so for this next problem, we have 2 minus 2 sine squared theta. And they want us to simplify that. And so what we're going to do is we're going to factor out first. So we have a 2 here, a 2 here. We're left with 1 minus sine squared theta. Now if we take the Pythagorean identity and we subtract sine squared theta from both sides, these will cancel, and then we'll be left with cosine squared theta is equal to 1 minus sine squared theta. And see how that's exactly what we have here. And so we're going to replace it with that. So we end up with 2 cosine squared theta. And that's it for that one. And now we have cosine squared theta sine theta plus sine cubed theta. So what we want to do is take out a sine from each piece. So we have sine theta, then we have cosine squared theta plus sine squared theta. And we see that our original Pythagorean identity right here, sine squared theta plus cosine squared theta, that's the same thing here because addition, it doesn't matter the order we write it in. And so that just goes to 1. So if we have sine theta times 1, we just get sine theta. Okay, we have a few more examples. So let's see. Okay, now we have cosine theta minus sine theta, and that's quantity squared. And they want us to expand that. So remember, we don't want to just distribute the squared. Instead, we want to write it something multiplied by itself. So we're going to distribute, so we get cosine squared theta, and then this times this is negative sine theta cosine theta, and then this times this is the same thing. And this times this is positive sine squared theta. And when we do that, these will combine, and we'll get negative 2 sine theta cosine theta. And if we have sine squared theta and cosine squared theta, that's the Pythagorean identity. And so those add together and they just make a 1. Because remember, sine squared theta plus cosine squared theta equals 1. And so that's our final answer on that one. Now they want us to factor. So we have cosine squared alpha minus sine squared alpha. And so this is a method called difference of squares. And it's where you write the square root of the first piece plus the square root of the second piece. And then you rewrite that, but you use a subtraction sign. And that's it. That's just a factoring method that you have to memorize. Okay? Alright, now we have tangent squared theta minus 3 tangent theta plus 2. So the first thing is we're going to treat tangent like it's x. So it's like we're saying x squared minus 3x plus 2. So we can t-factor to make them both negative. That means x minus 1 times x minus 2 is what we get. And so now I'm just going to replace those x's with tangents. So tangent theta minus 1 and tangent theta minus 2. Okay. All right, we have 2 more problems to do and then we're done. So we have 2 minus 2 cosine squared theta over 1 plus cosine theta. Okay, so the top, we can factor a 2 out. So that's 1 minus cosine squared theta. That definitely reminds me of the Pythagorean identity. So I'm going to see what I can do with that. So I have sine squared theta plus cosine squared theta equals 1. And if I subtract cosine squared theta from both sides, we get sine squared theta is equal to 1 minus cosine squared theta, which is what we have there. And so this is really just 2 times sine squared theta. So I'm just replacing this with that. Okay, so that's the top. Now the bottom, we have 1 plus cosine theta, and interesting, I think we could approach it differently. So if we do 1 plus cosine theta right here, that's one version of our answer, but we can actually take this, if we step back to this one, we have 1 plus cosine theta under this. We can use the difference of squares method on top. So it's the first one, sorry, the square root of 1 is 1. Square root of this is cosine. And then we can also do 1 minus cosine. So using difference of squares, we square root, do a plus sign, do a minus sign. And then we have 1 plus cosine theta. And so this cancels this, and then we can distribute the 2 back in to that. And so it's 2 minus 2 cosine theta. All right, that was kind of a strange one. Okay, we just have one more. Let's see if we can fit it right here. So we have cosine theta minus sine theta. Cosine squared theta minus sine squared theta. Okay. So the bottom will do difference of squares. So we square root, plus, and then minus. So cosine plus sine times by cosine minus sine. And then we have cosine minus sine on top. This cancels this. We leave a 1 for a placeholder. So we get 1 over cosine plus sine. If you need additional help, please come to Math Lab. Until then, calculator.